So, compute and inference is everything. And Elon just blew our collective minds at the All In Summit with his revelations about AI compute, the Tesla AI5 and AI6 chips, the future of Grok models, and the age of superintelligence that will drive the age of abundance. You may not understand it yet, but I assure you that this is Elon's most profound interview that he's given in a very long time. I've got Phil Beisel with me today. Phil is a visionary founder of tech teams at Apple and Rivian, driving innovation in the automotive and technology sectors. Welcome, Phil. Brilliant to have you on Over the Horizon. This is your first time, and I'm sure my audience is just going to absolutely love your insights.
I hope so.
All right. So where do we begin? There was just so much that came out of that interview. As I said, definitely by far the most profound talk that I've seen Elon give in a long time.
Yes, I think it was amazing. Actually, I think he kind of walked across the entire Elon ecosystem. Yeah, he didn't miss a beat, did he?
No, not at all.
No.
And so we've, the Tesla Bulls community, of which I am an avowed part, proud to say.
Yeah,
but
we're gonna have to wave in on that too.
So we've been talking about the convergence of convergences, right? And Kathy from Mark has also been talking about that. I kind of like to look at it as this past month or so kind of feels like we're nearing an event horizon. And this is the first of many event horizons, right? And there's so much of turbulence. There's so much of activity happening. There is so much of news that is literally breaking multiple times a day. It's beginning to feel a bit crazy.
Yeah. Oh, absolutely. I mean, if you just look across what's happening in the Musk companies,
Muskonomy.
Yeah, the whole Muskonomy, you're seeing a great convergence of different products and services that one thing feeds the other, and it's hard to keep your arms around because there's a lot there. There's a lot of moving parts, and they're moving very, very quickly, right? I mean, this is the thing. I think that what we're seeing is, we're seeing sort of on behalf of Tesla, we're seeing a great switch from an auto company to effectively a services company that will deliver labor as a service, transportation as a service, potentially energy as a service,
and intelligence as a service.
Yeah, and what we're seeing, though, that this is all really powered by AI, and the whole space that he has spoken about his deep investment into accelerated computing, and namely these AI chips, is really leading up to kind of a big event in terms of how it all comes together. It's very foundational, and he understands the building blocks to get there, and he has always picked the right places to vertically integrate his companies.
Yeah.
And doing the AI chips in-house, all but fabrication at this point, makes a lot of sense. And he leaned in on this earlier than most, which isn't surprising to anybody that knows him. But today's cars are powered with what we would call as AI4, which is the second generation neural processor that has been put in cars that has a Tesla brand on it. So hardware 3 started this, is now an older product, obviously, replaced by hardware 4, also known as AI4, as they changed the nomenclature. And before that, they were really focused on using NVIDIA and Mobileye in the cars, and that was, seems like a different lifetime ago at this point.
The whole debate around LiDAR.
That whole debate as well, that seems like it's starting to fade a bit as well.
Yeah, thankfully.
Yes. Yeah, so I mean, what we have now is Elon is signaling it's a great signal here. He's signaling to us that these chips are going to power pretty much everything he does.
Mhm.
And then namely the AI5 chip, which is due sometime in 26.
Yeah.
I'm sure they have early silicon samples now, and they're running that because he's talked about the performance that they're seeing on that chip, and then of course AI6. And if you think things are changing fast for us, they are. It's also changing fast for him because in the process of reimagining the hardware platform for AI through Tesla, he also canceled Dojo.
Right.
Um, and actually, it makes a lot of sense because at the time Dojo was conceived, the principal problem was training, and
Right.
the principal problem was training large data sets of ostensibly video data from vehicles. So this chip architecture was imagined to be largely capable for training. It was imagined to be low power ultimately, because he saw the need for so much of this compute, and that energy input would be a challenge. And so it wasn't just a chip. Dojo wasn't just a chip. It was an entire compute architecture around that chip. And what I think we're seeing is as time has marched on, as he's uh, felt the need or had the need to use NVIDIA chips for his training clusters, both at Cortex, which is the FSD property, uh, and then Colossus, which is the XAI training uh, training center, if you will, for the Grok models. He has effectively learned to pull those things together as large, coherent training clusters, right? So, in other words, the whole idea here is that not only are these chips fundamentally built on the idea of parallelism, that
Mm.
we can push tasks through them that are inherently able to be parallelized, which most of we could talk details about that, but most of the AI training and inference is all about, is all can take advantage of parallel compute. But not only are the chips necessary to build that, but when you're doing on the training side, you've got to pull together an entire cluster, which means thousands of these chips together to operate uh, as a delicate, as a dance, and to come through these epics, these dance epics, if you will, to produce. And what Elon has done is, because he's had the need, meaning Dojo didn't exist and came to fruition only as a reasonable prototype, he's had the need to build these coherent training clusters. This is a hard thing to do.
Yeah.
People listening need to understand how complex it is to get out of the box from NVIDIA. There is no single way to say this is how you pull a couple thousand of these things together. There is no simple way to deliver power for 100,000 GPUs in a way that, and as these training epics run and they bring power up and take power down, there's no simple way to create these uniform power to these data
Yeah.
centers.
By the way,
So
not many people know that it was, again, Elon and XAI that solved the problem of power for 100,000 GPUs.
yeah, it's so Elon understood this, was able to effectively build both Cortex, which is large by any measure, but then Colossus, which is much larger by other measures, um, as these coherent training clusters. So, in other words, what I'm saying essentially is, he said, "Okay, on training, I don't have a problem. What I need to do is I need to lean in on the inference side, which is the use of AI, because all of my devices, meaning Autos, Optimus, uh, will require very efficient and high throughput uh, inference chips, right? And what he has said in other presentations is that we will build a world-class inference chip for these devices, and it will be good enough. I don't know if that's exact quote, but good enough for the training side. There is a difference between a chip dedicated for training and a chip dedicated for inference, but he's starting to factor that out and be able to utilize the inference side for training as well.
Okay, so this is a little note to my audience. Those of you who are watching, I'm just going to pull up 2 articles that Phil has written, and this was the one he wrote back in October 2024, and this is a more recent one where he talks about inference compute that's going to explode. This is from September this year. I'm going to link them both in the description below the video. Please do go and check them out. Educate yourselves. Some fantastic insights from Phil there. So why is inference so, just one question before we go to the sound bites that I've culled from that All-In Summit. Why is inference so important right now?
Well, I mean, we have changed from what we are doing. I mean, if we a little kind of walk back on this, is that for 30, 40 years, we have built software as software engineers that we would call algorithmic approach to software design, and this has worked well with the hardware at the time, which is CPUs. And CPUs, of course, grew in their size, capability, speed. It became multi-core. But the problems, kind of the software kind of grew around the hardware, and everything was kind of in a happy place. You would be just looking for a faster processor for compute. And then something happened, which largely are these large screens that we're looking at. Okay. And the emergence of the GPU. And the GPU took a different, in the early days, if you go back years ago, there was no GPU in a computer. It was the CPU responsible for driving the pixels to screen. No,
Right.
it would hold a memory called a frame buffer. And the screens were small dimensionally. Their X by Y coordinates are fairly small. Okay.
Mm-hmm.
So now we want these screens that are 4K in size, and we want very dynamic video. You might think video games where you have high frame rates
Yeah.
and a lot of
Ray tracing.
a lot of texture stuff.
Yeah.
And so these things called GPUs started to emerge. Of course, NVIDIA really led the way there.
Yeah.
And they took the obvious in hand, which is that these screens are pixels and a lot of the operations can be done in parallel, right? So parallelism started to be a way to achieve greater compute. And even a CPU had some lean in on that, because multi-core is effectively a way to do concurrency, not necessarily exactly parallelism, but concurrency across.
Okay.
So
Right.
so the GPU kind of took it to a big next level, and our screens drove that. That was the first, screens and dynamic images like video games drove that market. And then came along something kind of crazy in the process, is that it was used for Bitcoin mining, right? Another process that could take advantage of that. Well, now we start to emerge in this idea of AI and the manifestation of AI being the neural network. Okay. And the neural network is essentially built on a set of math operations, which are what people would call matrix multiply operations. your classic linear algebra stuff. So the math of AI is actually pretty simple. It's very simple. It's just a bunch of adds and multiplies. Um, and these neural networks, both on the training and in inference, do millions and trillions of these matrix multiply operations, and they can be done in parallel. And so the GPU is perfect. It is perfectly aligned and architected to be the kind of product that gives us the opportunity to do this. If we did not have the GPU, we could not do the things we do today in AI. It would be literally impossible. Um, so there's this alignment where we had the right architecture coming along to meet the demands of something new called the neural network, which is really, if we think about AI is a big field and always has been a very, very big field. And it's kind of really converged down into this whole machine learning neural network, right? The neural
Right.
network is the way to go. And that we have recognized that most of the problems can be solved by large neural networks and by lots of compute. And so what we have now is, now that we know what our algorithmic process is, that is, we're using neural networks to solve these problems like full self-driving, robotics. Uh, we now lean in on inference, and we want the chips to be faster and faster on the devices,
Yeah.
as well as in the cloud, to do all those operations.
Right.
Right. I think what we found out also is that, a problem like full self-driving is so tedious. It's so difficult. It has such a long tail of potential, you know, uh, conditions in the driving
Yeah.
situation.
Edge
That
cases,
yeah,
outliers.
yeah, there's just
Yeah.
it's one of these problems that software people would say has a very long tail.
Mm.
It the tail is longer than the animal itself. And there's tons and tons of edge
Oh, it's
cases.
probably almost infinite, that deal.
It
Yeah.
really is. It's
Yeah.
and what we've learned collectively as a tech community, um, is that these things could not be solved by humans writing code.
Right.
That there was really, at the end of the day, there's really no way to solve it with a body
Close
of
to code.
code.
Yeah. Yeah.
So what we decided to do, and I shouldn't say we, in this case Tesla, we'll talk about FSD. Starting in version 12, Tesla decided to go what they called end-to-end neural, AI, a
Yeah.
neural network that dealt with both two halves of the autonomous driving problem, which is perception, which is really simple. I mean, simple to understand. It is perceiving the actual environment. The
Yeah.
car has eyes, with
Yeah.
cameras, and the idea of perception is identifying all of the objects there that are moving and non-moving, and knowing their locations, stop signs, road signage, any kind of road signage,
Yeah.
signals, uh, lane dividers, and then the dynamic objects, pedestrians, animals, vehicles, and anything else that's moving
Yeah.
in it.
I mean, in hindsight, Phil, it would look a bit obvious, right? Because we're talking about manipulating atoms or moving objects in a world built by humans for humans, perceived by humans,
Mhm.
as in photons in, controls out. And if we could do it with our meat computers, it would be sensible to take that path. I mean, hindsight is always 2020.
Yeah, it is interesting to look back and say, why was this not obvious?
Yeah.
Because if you think about this, even in version 11 of full self-driving, um, what I didn't finish saying was that we have the perception side, we also have the planning side, right? So planning is,
Right.
after we perceive this environment, we have to make decisions on how to move forward. And think of planning as something that's happening 15 to 30 times a second. It's not, there's obviously an ultimate plan, which is to arrive at your destination, but there is this idea that the car must compute its next move, to your point, about actuating controls, which are the accelerator pedal, the brake, and the steering angle, right? Those are the three primary controls that have to be decided. And so that problem, the planning and perception problem, you know, Tesla understood that the perception side was AI prior to version 11. That perception was an AI in process since, I don't know, 2016, 17 or so. Okay. Um, but the planning side, up until version 12, was still a code based, in other words, engineers wrote code to say, now that I understand this environment through perception, I'm now going to build a set of decisions that and that became untenable. Like
Yeah.
they couldn't reach a finish line because of all those conditions, that long tail. So they decided an end-to-end AI approach. And to your point, now in hindsight, it looks so obvious, um, but it wasn't obvious then.
Yeah.
And this approach is largely solving the problem. And
Yeah.
what it is doing, to your point, it is mimicking in some kind of light, kind of way how the brain processes and gets to that finish line of making decisions and driving. I mean, we sort of have a neural network. It's not exactly, these things are not symmetric. We're not
Yeah.
copying the brain when we call it a neural network, but we are copying the conceptual idea of how we think parts of the brain work. That's why it's called neural, as in
Yeah.
neuron. So yeah, now it's obvious that an end-to-end AI solution is the way to go, that we take sensor data, much like a human takes in vision. We process it through this kind of uh, through our brains. Which what I was trying to say is, and then we actuate controls. Okay,
Yeah.
and we do that as humans too. We make decisions. We change the steering angle. We push the accelerator harder. We push the brake
Yeah.
pedal. Um, what's super interesting is that the weird part about an AI, the weird part is that it's just a big box of numbers.
Mm.
It is, when we talk about a neural network, it is a set of layered out parameters that we call the weights and biases. And
Right.
there's a lot to that, but what the viewer should be thinking is that it's an approximation function. It's a function. It is, and
Yeah.
what's interesting is that the data itself builds the function. So what I mean by that is, in an AI, what we're doing is we're taking and driving samples that are captured by Tesla vehicles in the field. 5 million sensors running around planet Earth, driving on highways and uh, other types of roadways, and we're gathering that sensor data, and it's being used to train this model. And what it's doing is it's setting these numbers to some value, and it looks like, whoa, how does that work? But what it does is it is saying, I'm going to take past driving data and use it to build this function that tells us how to manage our controls. And it is this past driving data that is sort of predictive of the future driving state, right? So outside of crazy events, driving data can easily predict future states because there's only so many. But there's a lot. Okay. So
Yeah. It's
hence why a neural network is more
yeah.
able
And
to
when you
solve the
think
problem.
about it, Phil, it's just like it's almost as if we, and there's so much debate about whether we're in a simulation or not, but we seem to be creating this simulation, right? And if you look at the take a human child and how a child learns to stand and walk and then run, and that progression, right? um, which is a collection of learnings and inferences, really. And if you look at how humans learn to drive, again, there are so many parallels between the way AI is trained, and now even if you look at sim to real, which is a simulation within a simulation, some would argue. there are so many parallels, there are so many touch points that it's a bit odd that there should be so much of similarity. Or is that the nature of reality? And we're getting a bit metaphysical here, but
Well, I think, we as humans that endeavor to solve these engineering challenges uh, often are looking at our own brains saying, how do we do this?
Mhm.
And, there's a lot of mystery in there and how the brain works. And I'm not, that's not my area, but we've decided that it is time, in the trajectory of compute to start to understand these, what I call soft functions. And what I mean by that is algorithmic computing as a type of, when you write code, it's very logical. There is no soft edges. It's given an input, you will get an output,
correct.
and there's consistency to the input to output. And when problems get big, like full self-driving, when a problem gets that big, while we would love to have that precise consistency of a coded approach, we find out that we can't do it
Yeah,
because we can't um, understand all of which will present ourselves in the environment. This is why, an AI approach has been adopted, because it's just a different way of saying, it's in a way of saying we've given up on this coded approach because the problem is not boxable. We can't, yeah, we can't say
yeah,
where all the edges are.
yeah,
So if we come full circle with this conversation, what happens here at the end state is that we figured out that doing these AI models is the way to go. It is like, yes, it is the solution to the problem in many different disciplines,
yeah,
obviously emergent things. But we found out in autonomy, whether it's robotics or vehicle autonomy, that this is the way to go. So now what we want to do is put more compute in the car that can compute that type of thing.
right.
And so what's happening here is that Elon's saying, okay, well, an AI4 chip in today's vehicles, the ones that are coming from the factory today, having the AI4 chip, this is sufficient for version 13 and version 14 of full self-driving. It isn't sufficient for their end state.
That's a perfect segue to the two sound bites that I've culled from that Olin Summit. Let's just take a listen to them one by one, and then with your help for my audience, we're going to try and break it down and make sense of what Elon is seeing in the future.
There's
Yeah.
another part of the robot. So there's the LLMs, there's the actuation in the hands, but also there's the silicon that runs it. And there was, Dojo. I think you posted on X AI5 and AI6, and it just seemed like you were incredibly excited about the direction in which the silicon layer was also going. Can you tell us about that and what that is, and what are we building here? What is being built? Is it a complement to everything that exists in the world? Is it a potential long-term competitor? What is it?
At Tesla, we basically had two different chip programs, one Dojo and one Dojo on the training side, and then what we call, AI4, it's just our inference chip. That AI4 is currently shipping in all vehicles, and we're finalizing the design of AI5, which will be an immense jump from AI4. By some metrics, the improvement in AI5 will be 40 times better than AI4.
Wow.
So not 40%, 40 times. And this is because we work so closely at a very fine-grained level on the AI software and the AI hardware. So we know exactly where the limiting factors are. And so effectively, the AI hardware and software teams are co-designing the chip.
So a 40x improvement in the silicon, I think then as everybody here in the audience experiences it, is that just an almost like an order of magnitude increase in the quality of FSD and the safety that you experience as a Tesla driver, and then the quality of the robot? Like, where does it all manifest when you bring it up and actually get it into production?
Yeah, to be precise, the 40X is on, if you say like, compared to the worst limitation on AI4, which is running the Softmax operation.
Yeah.
We currently have to run Softmax in around 40 steps in emulation mode, whereas that'll just be done in a few steps natively in AI5.
Okay, so there's a lot to unpack there.
Yes.
It's very clear that so there were two parts that they were taking. One was training and inference. Dojo was training, and then you had inference, which is hardware 3, now hardware 4, which is AI4. And Elon just took an executive decision and said that, okay, it's pointless going down these two parallel paths. Let's just switch to one chip, one silicon infrastructure. And so we have AI4. AI5 is coming up next. And I just want to pull up this chart that you've got as part of your article to give us a sense of the numbers. 40x. What does that mean in terms of inference and capability, more importantly?
Yeah. So, okay. So where I put hardware 4, that's think AI4. They've just changed names here.
Right.
So, and that is the chip in the vehicle today. And he's speaking about AI5, forthcoming chip. It'll be due sometime in 26, mid 26, late 26. And he's giving us bigger numbers than what I have published here. He's saying that 500 tops is expanding roughly 10x actually, or more like probably instead of 2,000, 2,500 tops, it's closer to 5,000 tops. So roughly 10x. The 40x that he mentions is a special case, and he gets into the weeds on the Softmax algorithm, and it doesn't really require too much explanation. But
I'm also going to ask you to just break down Softmax and what it means for my
yeah,
audience.
well,
but a little later.
Sure. I think that the big picture here is that what he is saying is that he is achieving excellent performance on this AI5 chip. And I think that is largely what drove his decision to move away from Dojo and not make dual investments, because I think the team here, the silicon team for the inference chip, was performing, doing meeting his expectations or exceeding his expectations. So, but what's really important, I think the other, big picture thing here is that what he's saying is that the hardware team, silicon team, is working hand in hand with the software team. And this chip then therefore can be amazing because the designer of the chip, they know what the input is and what the output is in, say, full self-driving and obviously Optimus as well. They're working hand in hand with software. There are times, if you look at a company like NVIDIA, amazing company, obviously, the chip is built to be essentially horizontal in its approach. There's many different users of that chip. Some and many are doing neural network training. Many are doing neural network inference, but some are doing other scientific applications, and some are doing graphics processing, and some are doing Bitcoin mining. And what you end up with is a chip team that essentially designs to all problems.
Yeah, it's kind of a jack of all trades.
Yeah, and that's fine.
Too generalized, but it's okay for their business model.
It's totally fine, but it means that they can't build a precise solution. And what Elon is saying is, I can build a precise solution because I know what the inference use cases are, because my software team is sitting probably 50 feet away from my chip design team. And I tell you, from an engineering perspective, which is really my background, engineering and engineering management, That matters.
Yeah.
That's important. That's not a small thing to note. It is a big thing to note.
Yeah.
So
that's vertical integration right there.
yeah, that allows
Everything.
these two entities to come together. So why he brought up Softmax, which is sort of a maybe a funny thing to say, because knowing what it is, Softmax is an algorithm that takes a set of numbers and builds it into a probabilistic distribution. So like if you, let me give you an example. Let's say that you wanted to, in full self-driving, you wanted to recognize a traffic sign. And in the perception side, it came up and said that it's come up with some weighting on, they think it's 40 units of weight of it's a stop sign, and 15 units of weight it's a yield sign, and 10 units of weight it's a speed limit sign. And then you apply the softmax and it creates this probabilistic distribution. So it changes it into like percentages adding to 100. So now you change that into, I forgot my numbers, but yeah, like 62% it's a stop sign, and n% it's a yield sign, and n%,
Yeah.
and those numbers add to 1 or 100%.
Yeah.
So it's a process that occurs in the output flow. Like when you start with your camera data, you run it through this neural network. There are billions of matrix math operations, matrix multiply operations occurring. But when you get to the output side, you run these softmax. And what he was trying to say is that in the AI4 chip that's in today's vehicles, there is no facility in the chip to run that algorithm. Okay. So instead, they wrote a piece of software to do it, and they rely on a company's CPU to run that algorithm. And what he's saying is, in AI5, we brought it into the chip. We made it a native function. Okay, and that's there's a lot of little details on why you use. Who cares why you use softmax? What he's trying to say in the big picture is we've taken, because we're integrated, because the software team is integrated to the hardware team, we're able to go to the software team. Software team says, if only we had this softmax thing on chip, we would get better performance, because look what we're doing. And the chip team says, sure, let's figure out the 2 or 3 primary math operations, and we can include that on the chip native. And that's the big picture.
Yeah. So if I were to distill that down to its essence, it's just being a generalist versus being a specialist. And that is Tesla's advantage in optimizing whatever it's doing, and it's everything in its vertical integration by being a specialist. And that has implications for real world manipulation when you look at embodied AI, whether it's in the form of a self-driving car or whether it's in the form of a humanoid robot, correct?
Yeah, I think it's not that Tesla took it to some extreme point where the chip only does FSD. That's would be the wrong takeaway. The proper takeaway is, in these edge inference cases of autonomy, and I think we would add two elements in there, or 2 types of products. There's vehicle autonomy, there's robotics in the form of Optimus. In those use cases, he is honing that chip into a high performance chip. And on top of it, there's another condition, which is that these chips, if from my chart, they draw a lot of power. These are not the kind of inference chips that Tesla is building, are not the kind of inference chips that are in cell phones. Okay.
Right.
A cell phone can draw about 15 watts of power running full out, and no cell phone manufacturers allowed their products to be run that way on a continuous basis, because they would overheat, et cetera, et cetera. So they burst up to about 15 watts of pull for heavy operations. And use cases like FSD, this has to run continuously, flat out, 15 to 30 times a second, nonstop, with no blips. So it's a different beast. And the chips that
Crazy problem.
yeah, and the chips he's building draw a lot more power, a lot more power. So
Yeah.
you couldn't put one of those chips in a cell phone and have them really operate. But that said, the chip team, the design team is working very hard to make them the lowest possible power to meet the objective. So in a vehicle, we have plenty of energy to convert to power for these chips, right? We have plenty of energy store. We have 100 kilowatt hours in some battery systems on cars, enough to power a house for 3 or 4 days, right? In something like Optimus, we have maybe a 2 kilowatt hour battery, much bigger than our cell phone by, I don't know, I'm going to say 1,000 times. I forget what the cell phone numbers are, but still much smaller than a car. So these chips that are being built by Tesla, they have to run a tremendous amount of operations, but they also have to be power efficient, because without some power efficiency, we can't run Optimus for more than an hour a day or something before it needs to recharge, and that's not, suitable.
Okay, 2 questions. First, I'm curious to know your thoughts and your insight on this. So if you have hardware, so AI5, which goes into the robocabs and the entire robotaxi network, as well as Optimus, how much of an overlap is there in the sort of training data for the two?
It's a good question. So I've done some very deep dives into FSD, and I think I'm on part 6 of a series of articles on that, and it's been a process. If you read them back to back, you'll learn that I've learned too. That they've spanned about a year at a time, and I took a very general approach to the first one, and then I got more specific, and I went into different places, and I'm starting to go into a new place in the next version. And now, okay, having said that, I can tell you I know a lot about FSD. And when I say that, I also want to, put a little asterisk and caution and say that I don't work at Tesla. I don't have proprietary information. I don't talk to Tesla engineers. I read tea leaves. I look at, using my background, I look at what I see. I look at the hints from some of the engineers that post on X, and I say, oh, they're doing this, right? There's a whole article where I talk about a mixture of experts designed FSD, and it became very, very clear that they are actually doing that when they literally said they're doing it. Shak, who runs the, well, now he runs all of autonomy.
Ashok Eluswamy.
Yeah. He said quite directly that we are leaning in on a mixture of experts designed for FSD. And in plain speak, that just means that they're training little subcomponents of the network to be like components that can do intersections real well, and components that can do highways real well, and then components that can do rain and snow real well. And they're mixing them together in a process. So to answer your question, I know little less about Optimus. Optimus, there's 2 ways to train AIs today. There is imitation learning, and there's reinforced learning. And imitation learning is largely what FSD is. Okay. And what that means is it's taking vehicle data, it's imitating our driving behaviors, and that's how it's learned to drive. Now, there is a problem with that, and the problem is that humans are not actually very good drivers. So if you were, yes, shocking to most, but actually every single person listening to this will tell you, well, I'm a good driver, but everybody else is not. I hate to tell you, you all aren't very good drivers, and that includes me. So the problem with imitation learning is that you can only go so far, because and the way Tesla does this, it cherry picks it gathers just the right samples. It's not picking from the average driver, it's picking from the right driver, the good drivers. And so therefore it can easily edge up and meet the best drivers that exist in the fleet data collection.
Hmm.
But, and Elon mentioned this in that podcast, they are leaning in on a component called reinforced learning. And that is where they're doing the fine tuning of the model to then exceed human driving behavior or human driving safety by multiple factors, right? So how do you do that? Well, that's a big discussion, but reinforced learning essentially says that instead of trying to do the imitation learning where you're just pouring driver data through the system and training the neural network, you then add to it this component at the end, which allows the model to learn, build different trajectories and learn to do the very best thing, and be rewarded for it. And the rewarding, this reinforcement rewarding, allows it to train to do the right thing. So you give it rewards, like if a pedestrian walks into the roadway, there's a outsized reward to the training that says do not hit the pedestrian. There's some reward for not keeping lane, right? So imagine you're at the wheel of the vehicle, a pedestrian walks into the roadway. You want to avoid hitting the pedestrian. That's your number one goal.
One should hope so.
You should hope so. But you also have to be aware that you can't brake too hard because someone could hit you from behind. That
Right.
if you veer into another lane, you could hit another car. So it's a complex set of things. And reinforcement learning kind of deals with that problem head on. It gives you the greatest reward for not hitting the pedestrian. It gives you some reward for not getting rear-ended by the car behind you, and it gives you some reward for staying in lane. But they're smaller rewards. So the ultimate idea here is that it trains the model to do the right thing, which is avoid hitting the pedestrian. So to answer your question, how is it different from training Optimus? Optimus is probably more likely a more of a 50-50 mixture of imitation and reinforced learning. The imitation, of course, is that in this case, they're using kind of a human simulator. Sorry?
Teleoperation.
Yeah, the teleoperation. The human is performing the actions, and that is live data that is then ultimately trained, and the robot, the Optimus Spot's AI is mimicking those actions, much like you would mimic a vehicle. It's just there's a lot more actuation, there's a lot more controls, right? A lot more control outputs. But then there's this reinforced learning component to it, and I'd say that they are probably mixing those two kind of architectures of training more 50-50 for Optimus.
Right. And there's also sim to rail, and
Sure.
also training through videos, watching videos.
Yeah,
Yeah,
that's correct. I mean, the sim to real is really very much in the reinforced learning space, because this is how the vehicle does it, right? They take the driving scenario, they load it into a physics proper simulator. In other words,
Yeah.
it's going to, and then they add that pedestrian into the scene, and they
wasn't that what Ashok's team did, or they were forced to because they were running out of edge cases to train the model on?
Yeah,
Some form of that.
Yeah, if we come full circle, what did we say about this problem? We said it has an extremely long tail. That's where we started the conversation. So there's a point where you see some behavior that doesn't work as intended, but you have no training data to help you fine-tune the model, to fine-tune it out of the model. So if you see the car behaving a certain way in the deployed RoboTaxi in Austin, okay, and you say, well, we don't want that behavior. Okay, let's go find training samples. We can't find any. What do? We have to lean in on simulation. And I think Tesla's doing it in a very very cool way. They're taking their base level driving data and kind of loading it up as a scene, and then they're augmenting it with so for example, one of the things that they can do is they can let's say they have an intersection in Austin and they want to see how they perform through that intersection, and let's say it's very complex. There's some crazy turn lanes, and it's not uniformly symmetric. It's not 90-90, whatever. And so, there's kind of a crazy turn this way, and they watch their cars go through that, and they say it works pretty well, right? But they don't have any data that shows 50 pedestrians walking through the intersection. They don't have that. They don't have any training data that shows it raining hard and going through that intersection and trying to take a left-hand turn. So what they can do is they can take that intersection, load it into the simulator, and they can add all these elements in there. Crazy number of pedestrians doing erratic behavior. They can add snow, rain, accumulation of snow on the ground, snow in the atmosphere, and then they can see how the car performs in those environments. And if it performs well, they're happy with it. If it's not, they can build reinforced learning cases to further nudge the numbers of the model of the output of the neural network to adapt to that condition.
Right. Fascinating.
It is fascinating.
It is. It is.
Really
It's
is.
just.
It is a bit mind blowing. I admit that.
Yeah. It is absolutely. Yeah. All right. Let's get back to Elon's soundbite.
Sure.
AI5 chip will also be easily handle mixed precision models. So you don't have it'll dynamically handle mixed precision. There's a bunch of sort of technical stuff that AI5 will do a lot better. In terms of nominal sort of raw compute, it's 8 times more compute, about 9 times more memory, roughly 5 times more memory bandwidth. But because we're addressing some core limitations in AI4, you multiply that by that 8x compute improvement by another 5x improvement because of optimization at a very fine-grained silicon level of things that are currently suboptimal in AI4. That's where you get the 40x improvement.
You had keep going.
So now that said, I am confident that the current chips, AI4 chips that are in the cars, will achieve self-driving safety that is at least 2 to 3 times that of human, and maybe even 10x. Wow. And the software that will be released for that is coming out over the next few months. So version 14 will be the biggest upgrade in Tesla software since version 12. We are increasing the parameter count by an order of magnitude. There's a lot of reinforcement learning that's been used. There's like you can think of AI sort of as a way of compressing reality, and some of those compression steps were too lossy, and we addressed the lossiness in the compression steps. So these are all software updates that'll go out. So just over-the-air updates. Your car is going to feel like it is sentient by the end of the year.
That is pretty crazy.
God, someone like me just loves everything he said, but and understands. I mean, like, I'm smiling at half of the stuff he says because I get why he's excited. I know why he's excited. When he talks about memory, I know he knows he can load bigger models. I mean, every little detail there is meaningful and rich to him, and probably just translates to most people as, well, it's faster. But
that's why we get to talk to Phil Beisel, right?
Yeah. I mean, there's a lot. There's a lot there, and a couple things. I think the highlights of that clip is what he's saying is with AI4, the one that's in the car today, he can achieve the proper level of autonomy in the vehicle that can unleash. It can essentially unleash unsupervised onto AI4. He's basically telling us straight up that while I'm all excited about AI5, I'm not telling you I need that chip to solve unsupervised FSD. So
That is so mind-blowing.
yeah,
I don't
let's be
think people
clear.
have really wrapped their heads around what the implications of that statement are.
Yeah,
Because then, with the existing fleet of Teslas that are running on hardware 4, if you have V14 by the end of the year,
right.
the implications for the robotaxi network opening up and the Airbnb model also opening up, where you could just add your hardware for car to
Yep.
the network. And again, what that ties into the 2025 comp plan and the milestones in that. One of them is 1 million cars on the robotaxi network.
Yep. Yeah,
Boom.
that is what he said. You know,
Yeah.
if you read between the lines, he is saying that the current architecture in the vehicle is capable of unsupervised FSD, which is required for robotaxi operation. It is required for the scale out of robotaxi in his comp plan to 1 million units, commercial units. It is required for his FSD milestone, million units operating outside of robotaxi, because you're not going to get the adoption until you go unsupervised, right? Now, this is not to say that regulatorily speaking, that every market just sort of says, okay, let's allow unsupervised driving in our,
Right,
in California or whatever. But what it does is it opens up that window on his side, the technical box is checked. So
Yeah.
that's what he's
But
saying.
if you have the federal bill in place,
Correct. It's really saying we're no longer a constraint. We Tesla are no longer a constraint. So
right,
now we work on these other areas of constraint. But it unleashes unsupervised, and that's a big statement. And version 14 is a big model. Literally is a big model. It is 10x larger than the 13 model that drives today in the consumer vehicles, as well as some advanced builds of 13 that are operating in robotaxi and in the Bay Area where I live, as well as in Austin. And then he's saying, of course, now that these things are true, I'm building a next architecture chip to take it to the next level.
oh, by
And
the way,
yeah, and sometimes people ask this question, and I think I'll pose it and answer it, which is, well, if you said that all about hardware 4, why would I ever build the AI5 chip in the first place? Well, it's kind of like asking Apple why they build a A19 processor when the A18 did stuff very well on the previous iPhone, because
right,
better, faster, lower power, more efficient. You just keep, and you could see his numbers. He's 10x here, 40x here. But what that does is it suddenly adds use case that you didn't like. For example, today in Tesla vehicles, you can, in the latest software release, you have Grok operating in Tesla vehicles, and it's a voice. You speak to it, processes, it speaks back to you. However, all the inference is done in the cloud. It is not done on the car. So it requires that the car is connected to the cloud, and it sends the voice stream to the cloud, the bit stream of your voice. And then there's a part that converts your voice to text, and then there's an LLM, which is Grok, and then there's a text to speech, and then it sends back, the audio bits, and you hear that. That's all remote. It's all happening in the cloud.
yeah.
With
Talk about
AI5,
it is remote. Yeah.
yeah, with AI5, that can all happen native on vehicle.
Wow. Yeah.
Concurrent with FSD. So you're running FSD at 15 to 30 times a second. In fact, you probably on AI5 will take it up to 60 times a second. And then you can interlace, you can run concurrently Grok. So you can talk to Grok while the car is driving itself. And why is this important? Because the primary interface to the vehicle, especially robotaxi, at some future point will just be our voice. A customer will get in and they will not have to open up their cell phone and look at the app or touch the rear screen. They'll just say to the car, where are you taking me, or what highway are you taking to the airport? Oh, I don't want to take that highway. Or is my plane on time? What's the weather at my destination? You'll just have a very immersive conversation with this RoboTaxi agent. And so there are more use cases coming that's one I can imagine, and I've also imagined others. So more compute will be absolutely required.
Okay, so let's listen to this next soundbite from Elon again at the All-in Summit.
Some questions about Grok and XAI. You want to just give us an update? I think you kind of talked about where the next gen model is, and you said something incredible. I still don't think people really understand it, which is, there's going to be a next training run where you expect, not to start from the, common web and common crawl, where you expected an enormous amount of synthetic data. Just tell us about how the evolution of Grok is going and this innovation and why it's so important.
Yeah, so we're running using a lot of inference compute and reasoning to look at all of the source data, which is really the corpus of human knowledge, and then thinking about each piece of information and then adding what's missing, and correcting mistakes and removing falsehoods from that training data. So it's like, if you take, say, Wikipedia as an example, but this really applies to books, PDFs, the websites, every form of information. The Grok is using heavy amounts of inference compute to look at, as an example, a Wikipedia page and say, what is true, partially true, or false, or missing in this page. Now rewrite the page to correct remove the falsehoods, correct the half-truths, and add the missing context.
In terms of training Grok 5, you're scaling up your supercluster in Colossus and Memphis.
Colossus 2 now, yeah, but we have a second one.
Yeah, could you give us an update on that? And then also, as part of that, where are we in the scaling laws? If you scale a bigger cluster, do you get a more powerful AI model? Is there a point of diminishing returns? Or like, how much more compute, if you throw twice as much compute at it, do you get a 10% better model? Do you get a 100% better model? Like, is it log linear? What, I guess, how much more juice is there left in scaling hardware, do you think?
I think there's a natural logarithmic function associated with the amount of compute. So then, like, say for argument's sake, like 10x more compute will double the intelligence. Maybe that might be a rough rule of thumb. But that still means that you go from 100 IQ to 200 IQ. It's still pretty big deal. And I think we'll see intelligence continue to scale all the way up to where most of the power of the sun is harnessed for compute, and then ultimately most of the power of the galaxy. Sort of Kardashev 2, Kardashev 3 scale compute. So I guess once you think of artificial intelligence not as sort of this, a destination that you reach, but really as part of the overall escalation of intelligence that we are aware of. Human intelligence is also scaled as as the population has increased, and we've been able to store more and more information. Human intelligence is scaled now. Because of population declines and low growth rate, human intelligence is somewhat plateauing and will actually decline. And my guess is that I think that we might have AI smarter than any single human at anything as soon as next year.
Wow.
And then probably within 2030, Probably AI is smarter than the sum of all humans.
I think he's sandbagging a bit about ASI, but
I don't
and
know.
I would imagine that most people, their big takeaway would be, oh, AI is going to be smarter than humans next year. But what he said there is so deeply profound because he's talking about Kardashev levels 2 and 3 and the journey of AI evolution that we're on. And just to go back to the point about this entire debate of whether we can scale AI or not and how compute factors into that. Here is Elon telling you that it's almost limitless as he sees it right now.
Yeah, he's converted numbers of GPUs into just harnessing energy, right? In other words, he's told us out
Exactly.
loud that the problem ultimately is an energy problem. It's not, compute is what you need. You need to drive energy through to get compute. This there's two parts of this. The one was the Wikipedia part, which we should talk about. That's super fascinating. And the second
Yeah.
is just about scaling compute. There's this amazing and simple paper. I forgot the author's name. I should know it. Called The Bitter Lesson. And it's famous because what it says is the bitter lesson in AI is that through the years of AI, AI started many, many years ago, a long time ago. I don't know. It's been 40 years in the making.
Yeah.
Um,
Most people don't realize that.
yeah, and there's a lot of different technique to AI. Neural networks is just a small bit of it,
Yeah.
but it's the one that is the compute heavy one of the bunch, and it's the one that's winning. And this paper, The Bitter Lesson, basically says stop pretending that we can get to some intelligent state by mimicking some kind of special capabilities of the brain, like, say, playing chess and how we look a few moves ahead and then we do something in our brain to make us a great player or a mediocre player, and we don't know how to quantify that, and just compute 1,000 moves ahead in every possible way. If we can just compute our way, so in other words, it's almost dumb, right? It's like saying, if I can just run out all the potential moves, 1,000 moves to the point where they converge into taking the queen. That's how you win in chess, I think. um, um, that that I can just do that through compute, right? And so the application of this in the world today in artificial intelligence is building large neural networks, both on the training side and then running them on the inference side. And the bigger they are at some level, the smarter they are, and Elon himself is saying there's not a linear relationship. In other words, doubling the size of from going from version 13 to version 14 of FSD, that's 10x the number of parameters, does not equate directly to 10x amount of
10x.
safety. Or going from Grok, some parameter size of the Grok model 4 to the forthcoming 5 does not necessarily 10x the intelligence, but it may be 2x is the intelligence of the model. So, but what he is telling us is that we know how to scale this through. If you know, we know how to scale this by pushing energy through the system. And that's, we got to build these large training clusters. They have to be coherent. They have to operate as a whole, like one brain.
Yeah.
And the bigger they are, the more energy they need, and we have to harness more and more energy to make them bigger. So that was the second half of that soundbite. The first half is super fascinating. What he's saying is we have a corpus of data set that have largely trained AIs today. They are expression of human thought, right? They're humans writing words down. That in and of itself is a form of compression, right? Every thought that goes through your brain is not written down. It's the ones that you decide to write down. So therefore, you've taken some thought process and you've compressed it to some essence that you think is important. Clearly, you've taken a lot of thoughts out of that process to do so. And what we have on the web seems huge, right? It's a petabyte scale of information,
Yeah.
but in some sense, it's very small. It's very small. If we then
Because of the
add
quality of information as well.
quality is the next part of this conversation, I think. The second part is every book ever written since humans started printing books is also small by some measure, and certainly doesn't capture real world data. We don't know things about the natural world because we haven't really recorded it, if you will, right? So there's a whole box of data that's way bigger than what humans have collected in the written form that we are about to start ingesting in these systems, right? I could give you an example. But then the second part of that, to your point, is the quality of this data, right? We can look at Wikipedia and we can conclude through our worldview that it tells truth. But from somebody else's point of view, it doesn't necessarily tell truth because it's edited by a set of humans that come to bear with their own biases, their thoughts, their beliefs. They're not objective.
Yeah.
Okay. And so what we have in there is a misrepresentation of fact.
But then that
Right.
that is perspective, and I feel like, Phil, you're the perfect guy to have a metaphysical talk chat, perhaps in the next few days, about reality and the nature of reality and how we perceive it, because we see so much of what AI is doing is understanding the universe, and in doing that, understanding reality. And when you compress reality, you're adding the great filter, which hitherto was our brain.
Yeah.
And now you're doing it with AI.
Yeah, the idea here is that we're asking, or Elon is suggesting, that the AIs essentially generate information in a raw sense without using the human as the filter. And to his point, that gets to ground truth is one statement. And
Yeah.
two, it gets more information in the system that the human can possibly have
Yeah.
compressed through its course of history of writing things down.
Yeah.
Okay. In other words, we know today history is largely, most folks will tell you, historians will tell you, that history is written by those who won the battles, not lost the battles, right? But there's a lot more out there that happened, and we don't see all that because those who won the battles wrote the stories, and of course they wanted to say they were victorious and here's why they were victorious. But there's a whole set of underlying data, and when you go back through people that spent careers on this and tried to look at the Roman Empire and how it evolved and what the factors were, it's fascinating to listen to that because you realize that what's published isn't necessarily really ground truth.
Yeah.
But let's get out of that and say there are other things we don't know. We don't know at any given time how we move from spring to fall or fall to winter just in the natural world based on every little thing that occurs, right? Like how the leaves develop on the trees in the spring. We think we know. We say we study these things. We build PhD theses on components of these things, and we send people out to collect data, right? We send research science. We say we need to go out to confirm or turn over our thesis. We need to send people out to do experiments or just count things, right? And when they're done, we write these theses and we say, this is the truth. But then we realize that we have very shaky data. We don't have complete data. We have statistically incomplete data. And so imagine a scenario in a future state where we conduct that research through a fleet of Optimus robots that are just walking around observing, doing it at a much higher fidelity, accuracy, consistency than a human by
Yeah.
far.
By far.
We've gone from a data set that might be very, very small, and therefore possibly very shaky on shaky grounds, to a data set that's much bigger, not complete, but much bigger. And now we are interpreting reality. We're interpreting reality. For the first time, we are taking data that's come from a machine and training an AI without the human in the middle as the imprecise and flawed filter.
One of the
And
first experiments I would love to see AI run through is the double slit experiment.
yeah, it's a good one.
Maybe have an AI Schrodinger.
It's yeah, that's a fascinating one because it still blows everyone's mind, right?
Yeah.
Yeah.
But that's the nature of reality. And then when Elon said, talked about compressing reality, and I was like, it just immediately. So, which is why I say again, what he said in that interview is just so profound at so many levels that, we're going to be talking about this for the next months
I
and
think,
perhaps years as we begin to unravel the implications of everything that he said.
yeah, I think, I listened to that once, then twice, and I heard the words come out of his mouth, and I realized that he was putting on a compression filter of his own, and he was saying a certain number of thoughts that he thought would connect with you and me and other folks. And I could see that there was so much more he was thinking about. And, he has a beautiful ability to pause, think, and speak as opposed to just speak, and when he
Every
pauses
time
and
he pauses, there's that great filter of his.
yeah,
That's coming into play.
he's really trying to dial it down and distill it into sound biteable things that people can grab and take away, because he's really got a lot going on upstairs. And my takeaway is, to your point, he said so much there in that soundbite that I just tried to translate what I understood. And I have a lot more to say. We will never get through it. But I'm just trying to translate some of that. And I think my big translation of some of that is true intelligence means take the human out of the loop. Stop pretending that the human is the ultimate filter, arbiter, whether it's just bias or just information density. The human is not the object that will get us beyond human intelligence, because just like self-driving, with imitation learning, the best you can do in imitating a human is to get to human level safety. Even if you pick a bunch of F1 drivers, right? You'll get the F1 drivers. You won't get beyond them. So how do you get beyond them in terms of safety, right? You need to do something else. And I think that's really what he's saying. He's just saying intelligence requires true intelligence, not measured by how humans think. We need to get beyond that. We need to go from data to model with no human in the loop.
Yeah,
and
I love the way you put that. That is so, you've explained it brilliantly.
Yeah, it's the profound statement of the entire podcast, really. And it just, makes me realize that some of the stuff is so pedestrian as beyond that, right? Like, if you just think about the Wikipedia, okay, one of the hosts of that podcast asked a question: could you then rewrite Wikipedia, Grokopedia?
Grokopedia, yeah.
Think about what he said there. He is saying, we're going to go through what the human wrote, and we're going to essentially fact check it. Now, I don't know the technique. I have no idea what he's really saying, what his team has decided to do.
Yeah.
But what he has clearly said over and over again is that he finds that information flawed by omission, flawed by bias, flawed by so many different elements that are all about what us humans do in our, exceptional but also flawed state. And
Right.
and he's saying, I can't build a truly intelligent system by using that as my source. If I start with something flawed, I can't get to the proper finish line. If I start by something that like if you imagine that you just trained the whole world on the brain compute of a dog.
Yeah.
Dogs can do some really smart
Amazing
things, and
thing.
then
Yeah.
we look at them, we go, God, there's so much. They're not as smart as we are. Well, who do we think we are?
Yeah. Exactly. There's been so much in up until a few years back, this whole question of the black box algorithms and not understanding what's going on there. I think if I trust anybody, any AI company, and Claude perhaps would be one of Anthropic, and what they're doing with Claude, etc., would be pretty high up there. But the only ones higher or better than them at being more transparent and accountable, I would imagine, would be Elon's companies. And I think that the trust factor is pretty high there. And that's really important, because if you're building towards that level of intelligence, and Elon often says, curiosity, to make an eternally curious AI is the safest way towards achieving super intelligence and super alignment with the interests of humans. And I think he's right.
I think it may be of utmost importance for the preservation of humans in
Yeah.
the age of AI. Because remember how we got here with Elon? Elon founded, with a cast of others, OpenAI. He funded OpenAI. He was looking for an AI that was open. He was looking for something that was truthful. And he was looking for something and he was saying, what kept me up at night, I'm sure lots of things keep his brain running at night.
Yeah.
What kept him up at night was AI out of control, right? An AI that is in our worst nightmares. And two things I think occurred to him. The first thing is, if I don't participate, then I can't control. I can talk up the political side of AI. In other words, he can say, we need to set policy. We need to talk about this. It needs to be part of our discourse on building these. But then we're going to have rogue actors who don't really care about that. And whether they're foreign actors or they're just capitalistic entities wanting it to do it their way.
Yeah.
And they may not even be rogue in the sense that they're trying to be harmful, but they just might be harmful based on their own inability to understand that what they're doing.
Correct. And policy always lags bleeding edge tech.
And policy lags, and this may be a lag where we can't catch it, because we're dead. To be profound about it.
No, absolutely.
I mean, it's sort of like nuclear disarmament. You end up with the nuclear warheads. We know we can annihilate ourselves many times over, and now we go into the what's that?
A few words. We can wipe out a few words at least.
Yeah, and now we go into the policy debate of how do we dial that back and create treaties and so part one of this was that Elon said, I could spend all my time on the policy, the shaping, the public discourse, but I feel like I'll lose at that. And it's sort of the lesson he just learned through the whole Doge process in the US. I could spend all my time. Not a good plan. So the better plan from his perspective, the one where he can control, and I think that's the ultimate goal. If we believe that he's a good actor, I do. I believe he's completely earnest in what he's saying. I think it's literally what he says should be interpreted almost as what he thinks. Because any measured person who really understands him knows it's easy to read him. So what he is saying is, if I build this AI, I at least have a chance, because I'm going to go build a purely truthful AI. And the truth is what allows it to behave more like our ultimate trajectory as humans. I mean, I'm not saying that humans.
I was going to say that.
Yeah.
Eternally truth-seeking and eternally curious.
Assuming
we're supposed to be those things.
Yeah, well, we're sometimes the best example and the worst example of that as a species. And I always think to myself, if an alien, we always have this idea that why haven't we been visited by aliens? We must know that they're out there. Statistically, there should be out there. And I always think about this cartoon I saw where alien ship comes by and looks at Earth, and it just sees a bunch of people throwing rocks at other people and laughs it off and says,
not worth that time.
why am I, this is like a plant, it's like us looking down at ants and going, how interesting is this? And moving on, and we have this, self-centered, arrogant sense that we're so important that they must stop by and they must control us. And they just walked on by and said, there's nothing interesting here.
Not worth that time.
We'll come back when the planet's clean of that mess.
Yeah.
But, that's one view of it. The other view obviously is different. But I think what Elon is saying is this is a train in motion. This whole thing is a train in motion. And even I, Elon Musk, if I thought I was the most powerful person and I could create I can't stop this train. So I'm going to create another train. And my train is able to put checks and balances on the other train and probably get greater global adoption because we see it as truthful. And then as it's embodied, that the embodied objects like Optimus won't actually try to take actions that are, how do I say, harmful to humans, right? I mean, there's a lot of concern here. We know that if we just, if we go out and we get a German Shepherd and we train that dog, it's used commonly as a police dog in the US, and we train that dog to defend its master at all cost, we may get some very weird outcomes, right? Unexpected outcomes. The dog may not perceive the threat properly, may it may reach beyond what you, and therefore there's always a human there trying to call them off. Don't
Right.
do this, don't do.
Right.
But what happens when the human's not in the loop? What does Optimus do when or the human is talking to Optimus and Optimus feels no, I have to solve this problem. So the way to solve this problem is to kill all these humans here. And it's not like it's an evil object. It's just problem solving. Okay.
Correct.
And that's the threat. The real threat is it's just problem solving.
Yeah.
It's not necessarily got an evil core.
Yeah.
So it's very, very tricky to get this right. And I think when you hear Elon talk about that, you realize that it has kept him up night after night after night.
Yeah.
Because it is so tricky. And that he has arrived at a state where he thinks that a truthful AI, whether you like it or I like it or somebody else likes it, is the AI that will do the right thing, preserve the human species, and be additive, not subtractive.
Well, at least till such time that we have neural links and we can upload our consciousness to the cloud.
Yeah.
All right. We'll save that for another discussion. These are rabbit holes I'd love to go down with you.
I don't know
right
if that's
down
a
to the
discussion I
warren,
could
Phil.
even contribute to be honest with you. Yeah. That's a
All right.
fascinating one.
It is indeed. Thank you so much, Phil. It has been such a pleasure picking
most
your brain
welcome.
and just chatting with you about all things physical and metaphysical through the great filter of Elon. Thank you so much. Till next time.
Okay.